Hi everyone, we'll be starting by correcting the homework on page 33. Please check your answers. So for part A, I assigned the formal charge for each one and I've labeled the atoms 1, 2, 3 so I can know which formal charge is for which atom, and I've put in the formal charge on top here. And I also found the range of formal charge, so maximum formal charge minus minimum formal charge. So here the range is 2 and here the range is 3. So maximum formal charge minus minimum formal charge. And you can see that the range here is smaller, so this is going to be preferred. Moreover, you can see here the electronegative atom has a formal charge which is positive, so this is not going to be favored. And also you can see that formal charges here are closer to 0 in comparison to here. So then the first structure is a preferred structure. Now for the second question, I also calculated the formal charge of each atom in each structure as FC1, 2, 3 as labeled here. And you can already eliminate structure 1 because here the formal charge values are the furthest apart from 0, so range is 3. In the last two structures, the range is equal, but if you look at the formal charge of oxygen here, oxygen is the most electronegative atom, therefore it should have a negative formal charge. So even if both of these structures you find 0, 0, minus 1 and here minus 1, 0, 0, this is preferred because oxygen, being the most electronegative atom, will have the negative formal charge. So here the third structure is the preferred structure. So here I've mentioned the reasons just in case you are asked to justify your answer. Check your calculations and let's see the last question where you just have to find the formal charge on each atoms and to propose an alternative Lewis structure. So this is the formal charge of oxygen and this is the formal charge of xenon in this structure. Now in the preferred structure, we're going to expand the octet of xenon because remember, in the list of atoms that can have expanded octets, we have xenon here. So we are going to we're going to transfer the lone pair as bonding pairs so that we have double bonds here, so that the octet of xenon expands itself, and we'll try to achieve a formal charge of 0 for xenon. So for the formal charge of xenon to be 0, it should be 8 minus 8, right? So this is going to be here, this is going to be unchanged, so we can only change here. So 8 minus 8 would give us 0. So one way to get 8 minus 8 would be having double bonds here. So then 1, 2, 3, 4, 5, 6 double bonds. So then it would be 8 minus 2 plus 6. So then it would be 0. So let's try this. So it would look like this with a lone pair on the xenon and 2 double bonds with each oxygen. And if you find the formal charge for this one, so you would get formal charge of 0 for oxygen. And here, if you calculate for xenon, you would also get 8 minus 2 plus 6. So this would also be 0. So then formal charge of both xenon and oxygen is 0. So this would be the preferred structure here. It's an alternative structure. This is the last question, and we'll have to find 2 possible structures for ClO3 minus. I'm going to start by doing Lewis structures normally, and then I'm going to find an alternative one. So I have 13 electron pairs that I will place around the Cl, which is the central atom, like this, and 1 bonding pair. And then I'm going to add the lone pair. So 13, I have 10 left. So I have the 13 electrons placed in the structure, and this is going to be negative. Now, as an alternative structure, I'm just going to transfer a lone pair into a bonding pair like this, because remember that chlorine can have expanded octets. So this is the other structure that is proposed. This is going to be negatively charged. Now I'm going to find the formal charge of each one to determine the favored structure. Now, once you find the formal charge, here we have formal charge of chlorine is +1. Formal charge of oxygen is 0. So here we also have formal charge of oxygen -1. Now, the overall charge is negative, which means that these two, we can play around with these two to have the oxygen having formal charge of 0 and the formal charge of chlorine to be 0 as well. So we are going to try another structure where we move this here. So then it's going to be oxygen with 2 lone pairs and a double bond here. We can do this because chlorine can have an expanded octet. So if we recalculate the formal charge of chlorine here, formal charge would be 7 minus 2 plus 5. So this will be 0. And then the formal charge of this oxygen as well will be 0. And when you do the overall charge, you can see, so 0, 0, 0, -1. So overall charge is -1. So we have these two structures. If you want, you can propose another one, which we had just proposed, where you have chlorine forming 2 single bonds and then 1 double bond with oxygen. This is also okay. But as we found, based on formal charge, the one in the purple structure is the preferred one.